Okay, so I just want to welcome everybody to the R4DS book club for the data science online learning community. Today, we're going to be talking about chapter 27, a field guide to base R. DJ is going to lead us today, and we're going to kind of follow the same format we've been following, talking about highlighting some of the most important parts from the chapter, then opening it up for any like further discussion that anybody has of challenging topics, and then just focus on the exercises and we'll go from there. So DJ, with that, I'll turn it over to you.
Thank you so much, Colin. So I'm going to share my screen. Can you see my screen, right? Yeah, awesome. So yeah, the field guide to base R function. So mostly this chapter is explaining about the base functions, base functions in R. Mostly was a subsetting with the squared, single square, and the difference between double square brackets, and when to use a dollar sign when, and mainly discussing about the functions and loops also. So if we go to the exercise, this chapter is like mostly about explaining the subsetting of the vectors and the major difference between the single square bracket and double square bracket and dollar sign. So I can go with the exercises, and if anyone have any questions with the definitions, or we can go through it, or we can go with the exercise. Everyone is okay with that?
Yeah, I'm good to go. I don't think there's
Okay.
anything too challenging for me, but I'm sure we can talk more about
Yeah.
anything challenging when we get to the exercises. So
Yeah. You can see my screen, right? Yeah.
yep.
So yeah, the first problem is the first problem is create a functions that takes a vector as an input and return. So I'm taking example vector of this one, a set of numerics with a NA value, like a missing value NA, and the first task was the element at an even numbered positions. So I'm creating a function which takes a function as an input, vector as an input, and gives the even numbered positions. So this is the function I'm using for that. By taking the vector, it's sequenced by two, with the length of vector and by two, with the even number. So they have another question is like every element except the last value. So I need to remove the vector with the last value. So this function is about like removing the last value of that vector, and the third question is only even values and no missing values. So I need to create a function with taking an input as a vector, and need to create only even values with the no missing values. So basically it removes the NA values and only keeps the even numbers. So this is all the functions, and I'm using the same example for all these things. So if you go through with this function is this one, sorry. Yeah. So this one gives you like a 2, 4, 6 even positions. So only this vector gives only the even numbers, excluding the NA value. And when you go with the second example, like even with the last, by removing the last number, sorry, not even, only like just removing the last value. So it removes all the just the last value. And this one is interesting. Just it removes the NA value and outputs the even numbers. So this function helps you get like even numbers. So mainly the question was like just creating this, but taking as an input as a vector and doing these functions. So this is the first question. Um, yeah, does anyone have any questions on this thing to make it more simpler
So
or something? Yeah.
in your last function, you could also use switch, right? Because then you don't have to do the two steps, which gets rid of the NAs.
Oh yeah, we can use switch also.
Yeah. And the other thing I think is important to mention here, and I don't know if it's mentioned anywhere else in the book, it's that R is one index and not zero indexed, like the first position. So, I mean, I hated this coming from Python when I initially learned Python, and it was like, what the heck is going on? Why is it different? And yeah, So it's important for people to know, I think. Just
Yeah.
Yeah.
So this is the first question about this thing, and the second question is
Well, hold up here, hold up, DJ. I think
Yeah.
also too, I think there's some more conversation about like different approaches to it too. I leaned
Yeah.
heavily on the Modolo. That's like where I lean heavily on all of
Modulus.
these. Yeah, no, the Modolo. Is it the Modolo, right? Like the percent. So like
Modulus. Okay, I call
modulus.
it
Yep,
modulus.
yep.
Yeah.
Yeah, excuse me. Excuse me. So I use that mostly for most of these. But the only thing that tripped me up was the first one where it was like it's even numbered positions. And what threw me off was like, okay, you could use that. Um, like if it's a numeric vector, like you could just do like which and then use like the modulus and do that. But then I was like, well, wait a bit, what if you have a character vector? And I mean, I can give you like the example that I had. Like, what if you have a character vector like this, and you have to do something like this, where it's like odd, even 100 times, and you want to pull the even position. And I was like, okay, well, you can't necessarily do that with, modulus division. So what I had to
Yeah.
do is I had to do seek along to get the position, and then take
Yeah.
the position and then divide it and then switch it, using like using the exclamation point. So that's what I did for that question, to still use that same operator when it was like a character vector. But that was the only thing that really tripped me up with that, was like, well, you're going to have different types of vectors, and that's going to require you to do different things.
Yeah.
So
Yeah, that's a nice actual example. Like when we have like a vector of numeric not string values, it's very hard to do like a modulus thing. So this one helps, with those situations, I think so.
because this is what I did, and I can plug it into the chat if people want to play around with it. But like, this is
Yeah.
what I did to simplify it. Was I just did subsetting with seek along, plug in X, get the index, divide the index, and then just flip it from true to false, and then it would subset it out, just to kind of simplify that. And I think
Yeah.
this would even work for integer values too, or numeric values too. So
Yeah.
yeah, I leaned heavily on that because I learned that like several years ago, and I was like, this is the cool. I think for me, that is the coolest operator. Because it's just, there's some really neat applications with it. But anyways,
Yeah.
I don't need to say my love letter for an operator in R, but that's basically it.
So the next question is this. It took me a very long time to understand. It was very, I don't know, like it's not tricky. Yeah, I'm sorry. It took me a little time to understand. So the question is like, why is x squared bracket with minus x? Sorry, which is a function? I can explain it in the below here. Like if you see, it's not the same as x less than equal to 0. So it suggested we read the documentation for which function and do some experiments. So basically, which functions gives the position of elements with a condition. For example, here the condition is gives the position of element which is x greater than 0. So it basically outputs the position of elements with a condition. Which function does. So if you see the problem, like the question was x minus which x greater than 0. Basically, this function, like this thing, will be removes the positions from x condition. So this function pulls all the position and which will be removed from this x. So if you go through example, it understands little more, and this one also same. Like this also eliminates x value with a condition. Like for example, select the values with x which is less than or equal to 0. Let's consider it by taking an example of a vector with a mix of like negative values and positive values. So we try to give an output for this thing with that condition. So basically it outputs a position, not the numbers. So if it see like x greater than 0, like 0 doesn't count because it's not equal to 0. So it's strictly greater than 0. Then the position 3, 4 will be output. So it's a 3 and 4. when you do this for here, which will be the positions will be eliminated, like a 3, 4 will be eliminated. So it outputs a -2, 0, and -1, which is, and if you apply this condition, it outputs the same. But the question was it's not same because if you dig deeper, with considering another set with a NA value, let's take it this one, and we do the same. It outputs the same without NA values, and it still outputs the same for both. But the difference is when you actually it need to, like, when I searched in Google about this thing, it need to be gives a different one because this one is a subset of a number, whereas this one is like a what do you say, um, it's I think it needs to be gives a both different values, but I don't know, when I do identical function for both, it gives me true. So this tricked me a lot. So I mean, yeah, does anyone knows like what's the difference between that two?
I think what it's trying to get at is that what are you actually using to subset? So if you just run the what's in between, so like the first one with which,
Yeah,
if you run which, you're going to get a vector of negative values, right? Because you have the
yeah,
Boolean, which is x greater than 0, and the output of which would be the position where those values meet that Boolean expression. And then you're like, what I don't really understand, the weirdness of this is the negative, where it like
yeah,
applies a negative to each one of the values that gets returned. So then what you're actually subsetting by an x is like a -2 da 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 da. But then when you're using this like expression of less than or equal to, you are getting a vector of Booleans, true or false. And so when you subset by true or false, you are subsetting by a different type of vector. And so I think that's what it was
okay,
trying to get. Yes, you get the same result, but the
yeah,
subsetting is different because you're using a
exactly,
different type of vector.
yeah.
I don't know, Stefan, if you
So
want to add some more to that. I think that's the way I understood it, but I could be wrong.
yeah, so this question was a kind of tricky. So yeah, but when I do identical, it's supposed to give me a false because these function outputs the same result, but the what is the type of the character will be different. But I don't know, it's giving us true. So this question was very kind of tricky for me.
I actually think
I
you didn't rerun the X. Did it? You rerun the whole code chunk. I think when you got the true, you might not have run the code chunk when you check the identical. Run the
Yeah,
whole thing, yeah. Did you get I can't see right now. Is it a false or a true what you get in the bottom?
it's true
No, but in the console,
in the
Oh,
console. Yeah, it's true.
it's true.
Yeah.
I get false when I do the exact same code you have.
really? That's funky.
Yeah, it
Oh,
needs to
wait,
get
wait, wait.
false
Maybe,
actually.
maybe no, I made a mistake. I made a mistake. Okay, I made
Maybe
a
with
mistake.
a less.
No, I have a mistake. I see now.
Yeah. So this question was kind
Yeah,
of
okay,
tricky for
no.
me. Yeah.
Yeah, no. Yeah, I also don't get it. So I don't have anything to.
I think it's supposed to be a trick question because
Yeah.
it is going to be identical because it's going to return the same thing. However, like so DJ, just if you just highlight, so line 60, if you just highlight the negative, which just run what's inside of the brackets. Don't run the whole subset. Just run that and look at it. So you get the position -3, 4. Now on line
Yeah.
63, just run x less than or equal to 0. So then you're getting a different vector. Okay.
Yeah.
So you're subsetting it. It's still going to subset the same things, I think, correct?
Yeah.
Yeah,
Yeah.
it
Yeah.
should. And I think that's the trick, because if you dig into like the which documentation, what it's going to do is the output of which is give the true indices of a logical object, allowing for array indices. So it's similar, but one is subsetting by position and one is subsetting by Boolean. That's the way
Yeah.
I understood it, but I could be totally wrong. I don't know, but that's the way I understood it.
Yeah. This is that question about like this thing. And the next question is like, it's about like a difference between this single square bracket and double square bracket, and what is the major difference between. And so yeah, what happens when you use this double square bracket with a positive integer that's bigger than the length of the vector? And what happens when you subset the name that doesn't exist? So what is like if you see the difference between this, the double square brackets to extract a single element from a list or a vector or any structure. So it's basically it's like it targets only that specific element which you send into that double bracket. Whereas the single squared bracket, it extracts multiple can extract multiple elements also. It's like it just take a part of that already exists. If you see the example, so I consider a list of A, B, C elements. If I put like a, okay. So if I put like a double square bracket for this one, it outputs, it's like an error and it's a script out of bounds. So if I do with, this is with the, this vector, and if I do the names, like a names of a V with a first, second, third, and if I still do the like a fourth element, actually it's supposed to return null because of this functionality, but I don't know this one give me output of this one. Basically, this one only gets when it's integers are passed, I think so, according to the script I've read. So when you pass like a string with the fourth element, like any element out of the vector, it's supposed to return none. Yeah. And if you see here, uh, yeah, so if you use a single bracket, it gives you NA value for the both. Whereas the if you use a double bracket, it gives you like a out of bounds or a, it's supposed to return null, but I need a question, like I need a suggestion on this thing actually. Yeah.
Yeah, I got the same thing. I got the same errors. I mean, just using a different example, but the same errors was the
Yeah.
out of bounds. Initially, when I saw this question, I was like, oh, recycling rules are going to take over, was what I thought.
Yeah.
But that was not the case. It was subscript out of bounds. But you do raise an interesting question between like using single brackets and double brackets. And I think that gets at like what you're actually subsetting. Double brackets would be the specific element that you're subsetting, and then like the single is just a list, right? It's always returns
Yeah.
a list.
Yeah.
So if you have nothing, it's always going to return a list. So you can always have an NA list, correct? I would venture to guess that if you put type of, like a function type of around V5, it would probably return of type list. Type of, use type of. Yep. Oh, it's a character. Interesting. I thought it would have been a list. Because I
It's
always
just a
thought that.
vector. It's just
Oh.
a V is a vector and not a
Yeah.
list object.
Yeah.
Or is it okay? So maybe I misspoke, or maybe I misunderstood this. Is the single bracket always going to return the type that was originally submitted to or using for subset? So if like V is a character vector and you use a single bracket subset for that, it's always going to return the type of what the original object was. But then the double will go down into what the element within that object is. That makes sense?
I
Or
can't
here,
fully
let's.
wrap my head around it. I mean, in the chapters, it literally says selecting multiple elements with a single bracket and a single element with a double brackets. But I also don't fully grasp what that means.
Okay,
Yeah.
so go ahead, DJ.
No, that's what I was saying. Actually, Evan, I have a question for this also. Like, if I pass this one with the names of V, it's supposed to return me a null, but it's getting me like an out of bound. Do you have anything about this thing?
I think it's because a vector doesn't have anything nested inside. Like a vector is just a vector. So if you would do the same thing with a list, then it probably would return you null, is what I assume. So if you just write list instead of C and then, where would it be? UV in line 81, you just make a list out of it.
Yeah.
So just replace the C with list. Run that.
Okay.
Well, you don't have a
It's
fifth
still out
element.
of bounds. Okay.
This
It
one is
doesn't
okay,
return
but
null. Okay.
this one let me turn this into list.
No, that's those are just the names. Now you are assigning names to the list. So just leave it as C, I think. I actually don't know how naming lists works. I usually just name the elements right away.
Oh, it's getting null actually.
Yeah, there you go.
Yeah. It's supposed to give me null. Yeah, but how? Okay. Somehow, yeah. So when you pass like names with the string, it's supposed to give a return null. Yeah. When you pass the integer,
A list of string elements. Like I think that's the important thing, right?
yeah.
Okay.
So
Well,
yeah, this is the question.
that's weird. Okay, wait a minute. Let me wrap my mind. I'm hijacking
No,
this. I'm just trying to wrap my mind around this because this is an interesting difference. We changed originally it was a character vector or a vector of string elements of characters, but then we changed it to a list. If we tried to subset that using a index number that was outside of the number of elements within that list, we get a subscript out of bounds, correct?
Yeah.
Okay. Just making sure I'm saying here. But if we apply names to those list elements, and then we try and subset by a named element that does not exist in the list, we will get a null value returned.
Yeah.
Wow. Okay, that seems.
Yeah. It's not a list. It's like a vector. Yeah.
Well,
It's
lists
a
are
list.
different than vectors, right? Lists are different
Yeah,
than
it's a
vectors.
list.
Yeah.
It's a list right
Okay.
now. Like if you do a type check on the V, it should give you a list.
For this one, right?
Yeah.
Ah, this one. I was talking about this one.
It should
But
still be a list. Oh, go ahead.
the vector you provide, the C here, that with the names, it's just providing the names. It doesn't change the
Yeah.
type. It's still V stays a list at this point.
Okay.
Okay,
Like-
here's okay. Oh, go ahead. Go ahead, Stefan. Sorry.
No. Go.
Okay, so let's for just okay, so let's copy line 89 twice. So let's copy line 89 twice. Okay, so copy that. Just copy it twice. Give it another copy. Okay. Line 90, wrap type of around that. So the function type of, which it should be a list, which we've been saying. Okay.
No, this
so
will
run
be
that.
character. This will be a character because you get the.
Oh
no,
yeah,
this
yeah.
will return null. So I don't even know what it will tell you.
Oh, it
it's
will be null. Yeah, duh.
Yeah. So,
Yeah.
but if you put first in instead of fourth, then it will give you character because what you extract is a single element of that vector, right? Of that list, right? And that is
And it does. Now on line 91, wrap that in type of. change it to first, and then do
And
single
single
bracket.
brackets.
Yeah.
And that will be a list. Yeah.
Sorry, I'm driving the boat and having to do these things, but so if you run that, that should now be a list.
That's yeah.
So going back to my original question with the start of like, okay, if we're doing single bracket subsetting, it's always going to maintain the original type of whatever's getting subsetted.
Yeah.
Is that correct?
Yeah.
Okay. I think,
Yeah.
and I'm going to put this in the chat. I know this goes beyond this conversation today, but I think there's a section in Advanced R that has like a similar kind of like analogy to like make this more concrete. And I think the pepper shaker one does pretty well, but I think this one does a little bit. This one was where I actually like really understood it. And it's not too challenging to understand. I know it's from Advanced R, but it's like one of the earlier chapters. But this, I think, really clarified that like single object grab kind of thing. Because a list can hold anything, right? A list can
Yeah.
hold vectors, it can hold a combination of other lists and vectors, it can hold function definitions like lists. So like when we say single like subsetting, like you can pull anything out of it. So anyways.
Yeah. So yeah, this is all about this question, which is the major difference between a single bracket and single square bracket and double square bracket. But we will get deeper into the example of the pepper. So I have taken here a list of a vector and the other elements like strings. So if I run this like with this two double square brackets, it will list me with this vector. See example here, like red, green, yellow, which outputs this vector. If I do like three, it will output me with a sweet. So if I do like if I want to like get into this vector with a red or a green or yellow, so I should pass with the double with a single list here. If you see here, so it will basically this one goes into the first vector and first element with a single bracket. If I pass, yeah. So yeah, if I put like a double brackets for the one and one, then it returns red. So yeah, returns a subset, still a vector, and this one returns a single value directly. So, yeah.
Oh, I
Yeah, I did
think
some.
it was
Go ahead.
going at the sorry. I think it was
Mhm.
getting at the analogy of the pepper shaker, right? If you go to the book and it shows you, okay, if you have the list is the pepper shaker with the pepper sachets in it, then the
Yeah.
single bracket is like a single pepper sachet in the shaker, and then the double bracket would be just the sachet. Do you mind? Do you have the book so other people can see what I'm talking about? Do you mind
Yeah.
navigating to the? Anyway, so I think in the analogy, when you do the single bracket, you would get
Can you
the
see my
single
screen?
bracket, you would get still a single peppercorn or whatever is inside the pepper sachet. And with a double bracket, you would get just a single peppercorn and the sachet is gone. I think that's what it's aiming for in the analogy.
Yeah. So yeah, this is a usage of this like if I have like a list with a vector inside and I have different elements, you can use like a double brackets, a double square brackets and a single bracket for the getting out the data from that list. So yeah, that's all the exercises which covers the chapter. Yeah. Do you have any other questions or anything?
No, I like the way you put that stuff and that makes sense. I was just wondering, I was kind of sitting there thinking about like if I was confronted with this and I had to write dplyr code to pull it, what would be the dplyr verbs that I would need? would it be like pluck and pick? Would it be like, because you would have a
No, you do
list?
maps. You can do map. The map functions also can pull out information based on position or name.
Oh,
I'm
that's
pretty sure it's
right.
been some time. Jenny Bryan has like a pretty good sources on how to use map to work with lists, because I find it always so confusing. But the map functions or the apply functions would be the things you use to get deeper in it.
Yeah, I do remember that now. Like you can use map. There's a way you can use the map functions to subset as well. So it's not
Yeah.
necessarily just about applying or iterating or applying something over a multiple
Yeah.
set of elements over a list. It could also be that too. Okay, that makes sense. Yeah. That's interesting. Okay.
Maybe I can find the link to this.
Because I know you have like if you were dealing with like if you were trying to, and they kind of mentioned this too in the book, like a lot of these a lot of these operations that you can do can be translated into other verbs from like the tidyverse. The one that I kind of always go to is just like pull, so you can always do pull, which should pull one element deeper. So like if you had a tibble, you could pull a column and then pull
Oh.
a element out of it.
Does it
So
work with a named, just with a named list or with a?
that's
I'm
where I thought like
curious.
because I remember there used to be a verb called pluck, and I don't know if that's still around or not. Because I thought there was like so DJ, if you go back to our studio and then like do library tidyverse and then do question mark pluck.
So I think here when I look at pull, it says it is a data frame extension or lazy data frame. So I'm curious if it would work with a list. I doubt it.
Extract a single column. Well,
Okay.
well, a tibble is just a list of vectors. But your question would be, would it work just on named list elements? That's a great question. I don't know.
So I just ran a code. Let me just paste it here, and that gives the error no applicable method for pull applied to an object of class list.
That's
So I don't think you can do that. But when you do the map functions, I wonder how this works. I was trying to look it up, but I couldn't find it.
plus one, left 1 through 2. No, that does not. C2. Oop. Nope, that does not work either. Oh, interesting. I don't think it works on the list. Yeah, because well, I thought a tibble was just basically a list of vectors. But I guess a list is
Yes,
different than.
but I think the pull function itself must check the type of what you provide. And so it has to be like, yes, what is this would be the superset, but it asks you for a subset of things. Does that make sense? Like a
Yeah.
data table is a subset of lists, and it specifically wants a data, sorry, not data frame. Yeah, that's I think why that doesn't work. Here I put in the link for the per tutorial, and there is the map thing.
Oh, nice.
There's
Yeah,
some
yeah, yeah.
example with map, so you can use, yes, you can use the position or, yeah. This is as an example, a nested list. I don't know. But that definitely is a very nice tutorial. I remember, I forgot all about it, like how to actually do it. But I remember I was like, oh, this makes a little bit more sense now how I use map functions to get at elements.
Yeah, it's been a long time since I've had like a really deeply nested list that I've had to work with. So, I mean, if you get past like list elements. I mean, I know like if you're working with like JSON, you certainly can get some deep levels, but I don't really work with JSON very much. So if I usually am in that situation, it's like I have to go look up how to remember how to do some like deep subsetting of individual elements. And yeah, I remember that. I remember that was one of the neat tricks I remember about one of the map functions is like you could also use it for subsetting. And that was a really nice feature, um, which is kind of cool. But I would also look at pluck because pluck is kind of cool too. It's just a dplyr verb that lets you like deeply like lets you like go into a list and pull out stuff using a verb rather than like using the map function to do it. Because I think you can go several layers deep. Let's pluck. So check that one out. Cool. Well, I appreciate leading the conversation today, DJ. This was good conversation. It's always good to go back to base R a little bit because you always, I mean, there's always some there's always some like efficiency from knowing base R, and you obviously will come across it when you're writing code and seeing code because people do a mix of it sometimes or they only use it. So it's good to see and kind of talk about those some of those conventions. So all right, cool. Well, I think we can wrap up for today unless anybody else has any other things that they want to add. All right, cool. Well, next week we'll look to wrap up the entire cohort and talk about chapters 28 and 29, and I'll put myself up for leading those and we'll go from there. So other than that, give everybody 18, 17 minutes back. So have a good rest of your day.
Thank you.
All right.
Bye.
Here, see you guys.
Bye.